Okay, we are starting arithmetic and geometric series today. Now, a series is when I want to go ahead and take terms of a sequence and add them up. Doesn't matter if the sequence is arithmetic or geometric. There's formulas that go with these. And actually on the homework, I don't know if we looked at it last week. We didn't look at it today, but it was one problem discussing how to find the number of seats in a section at a ball game. Okay, and for those who did ask me about that question, all we could do at that point was basically generate the sequence and then just add all the terms. But now with our discussion here, we're not going to need to do that anymore. In fact, we have a problem coming up very similar to it. Just a few things about what's going to be happening in the very near future. What's happening in 2 days? Okay, your exam. So the exam will not cover this material. It will not have series on there, but it will have sequences, arithmetic and geometric sequences. Basically, your homework assignment, that's what you can expect on the exam. Okay, those type of problems. And I really don't think I put application problems on there. I think this one's more just a straight skill set. Okay, because we're moving a little faster now. I wish we had time to do that. But speaking of time, next week is already the end of the 6 weeks. A week from Friday, the 5th is over. We've only got so many grades left. The homework we just turned in, we're going to have the exam grade. There's the focus activities we're going to turn in next week. You'll get number 3 tomorrow and probably number 4 early next week. But we're losing another day next week because of the what? District assessment. We have to give that this time around. And then the week after next, we're losing, I believe, 2 days that week for what? STAR testing begins, the English 1 and English 2. Not to mention in May, where you have the full week of the algebra, social studies, biology. So kind of thinking about, long term, we've got X number of days left in school, but we've got Y amount of material. So we're just going to see how we can do getting to the end. Because after this is our last lesson on sequences and series. Then we need to talk about the binomial theorem. And basically we have 3 topics left after that. Conics, parametric equations, and then polar equations. So we may not be able to get far with polar equations. It really just depends on the time we have remaining. So let's go ahead and get on with this then. So we're going to talk about series. Now, summation notation is the sum of the terms of the sequence denoted as, and this is a Greek letter we call sigma. In mathematics, we use that to denote a sum. So there's a couple of things here. The bottom value is the term number that you start with. The upper value is the term number that you're going to stop at. And then what follows, that's the formula to get the value of the terms themselves. So like the example here to the right, I want to take the sum of the first term to what term? To the 7th. So I only want to go through the 7th. And the way I generate those terms would be k squared. So the first term would be 1 squared plus. And for the second term, k would equal 2. Well, I plug it in again, 2 squared plus. Third term, k equals 3. 3 squared plus ... all the way to the last term I want, 7 squared. And that's what a series is. Instead of just generating the sequence, we're going to be adding the terms of a sequence. Sometimes all of them, sometimes not all of them. Okay. But that's what we're going to be doing. Now, the index of summation, that variable we use is k. But it's not the only one. You'll notice in some other examples, we have n here. N is perfectly fine. In fact, the variable itself does not matter. For those of you who are going to be moving on in calculus, who are going to be seeing Mr. Heinrich next year, he likes to use the variable I a lot when talking about summation. So the variable itself is going to change, so don't let that bother you. Okay, so a blank series is the sum of all terms in a geometric sequence. Well, that would be a geometric sequence, or geometric series. A lot of the vocabulary today is pretty much defined in the definition itself, okay, the term we're looking for. So this one here, okay, I want to start with the first term, go to the 13th term. So I want to add the first term all the way through the 13th, and how would I find those terms? Well, I would use the formula negative 2/3 to the n. What follows is always the formula to generate that sequence. Okay, so in blank series is the sum of all terms of an arithmetic sequence. An arithmetic. Okay, and you'll notice here we have a linear function, 2n minus 5, to represent the explicit formula. But here I only want to go from what term to what term? I want to start at what term? So starting with the 8th term, I want to add them all up until I get to the 15th. Okay. And then in infinite series is one in which an infinite number of terms are added. So it is possible, but it's very dependent on an idea we discussed in the last lesson. Okay, you're only going to be able to find the sum of an infinite series if the sequence does what? What do you think I'm referring to? What's one word out of two that we spent a lot of time on in the last lesson? Converge. Okay, only if it converges. And actually what you're going to find to what it converges to is the sum that you should end up having. Okay, so here we want to start with the first term. We want to go forever, and it's 1/2 to the n. And that makes sense. This guy's going to go to 0. Okay, so good. And then we have a couple more definitions here. A blank series is one in which a finite number of terms are added. So that's a finite. Okay. Now, the one thing I did go ahead and put here that I want to go ahead and mention, I put notice the number of terms. Okay, so look at this summation notation, sigma. I'm starting with what term? The 3rd, and I want to go to the 6th. Okay, so how am I going to find the number of terms? What could I do with the upper and the lower? If I want to know the number of terms that I'm going to be adding total. Yeah, just subtract them, right? But 6 minus 3 is 3, and how many terms am I adding here? I'm actually adding 4. So this is where you have to be careful when dealing with summation notation. When you subtract off the lower value, you're actually removing the first term in the series that you wanted to go ahead and add. So you're going to have to do this. In order to find the number of terms, you're going to take the upper value minus the lower. So the term you want to stop at, subtracting the term you're going to start at, but then you're going to add 1. So you do take the difference, but you go ahead and add 1. So 6 minus 3 is 3 plus 1 gives me the 4 terms. And that makes sense because if you think about it, 3, 4, 5, 6. There are 4 terms that I would be adding. Okay. And if we go back and look at some of these examples that I had previously, all right, like let's say I want to start at the 2nd term and I want to go to the 9th. How many terms will I be adding total? What's 9 minus 2? 7, but then I add 1. So there should be 8 terms in that series. Okay. If I want to go this one here from the 8th term to the 15th, how many terms will I be adding? Let's see, 15 minus 8? 7 plus the 1. So I'll be adding 8 terms. The only time you really don't have to do this is if you start with the very first term. Because take a look at this one here. What's 7 minus 1? 6 plus 1, so it gets you right back to 7. So the only time that doesn't apply is if you start with the first term. If you don't start with the first term, you have to remember to add 1, and it's really easy to forget. Okay. All right. And then our last one here, a partial sum, is the sum of part of a sequence. So let's say I have an infinite sequence here, 2, 4, 6, 8, 10, 12, ... But I only want to add a portion of those terms. So 2 plus 4 plus 6 plus 8, that would be a partial sum. Would there be any way to go ahead and add up the infinite sum? Does this converge or diverge? This diverges. You can only get an infinite sum if it converges. So there's no way I could do that. These values are just going to keep getting infinitely larger. Well, they're going to go to infinity. I mean, they're only increasing by 2, but you understand what I mean. Okay. And then here are my formulas. If you're looking to find the sum of a certain number of terms of an arithmetic sequence, Here are my two formulas. Of course, S refers to sum, okay, sum of a certain number of terms. But there's two things you absolutely have to know in order to use either formula. You have to know the first term for sure. So if you don't have that, you need to maybe do a little bit of calculation to figure it out. But what's also another value you need in order to use either? What's in both formulas? N. You need to know the number of terms that you're going to be adding together in an arithmetic series. So if you only know the number of terms, the first term and the last term, this first formula is going to be the one you'll want. Okay? But if you don't know the last term, but in its place you do know the common difference, well, that's when the second formula is going to be more useful to you. So it just depends on the information you have. All right. In fact, you'll notice that second formula, it's very, very closely related to the nth term of a arithmetic sequence. A sub 1 plus n minus 1 times d. Remember, we use that a lot on the homework. In fact, will either of these two formulas show up on the test? Okay. No, right? But will this guy show up on the test? Absolutely. Absolutely. Okay, well, let's try a problem. Let's see what you guys think. It says a corner section of a stadium has 8 seats along the front row. Each successive row has 2 more seats than the row preceding it. If the top row has 24 seats, how many seats are there in the entire section? So here, the term number is the row number. So the first term in the sequence is the first row. The second term is the second row, and so on. Okay, the value of the term is the number of seats in that row. Okay, so what would be the very first term in the sequence? 8. So the first row, first term has 8 seats. What's the common difference? Yeah, each next row has 2 additional seats. So that's my common difference. So you could say 8, 10, 12, ... all the way until you get to 24. Okay. So we know that the nth row, the last row, should have 24 seats. Okay. There's only one problem. Look at all the information that we have. Now look at my formulas. Can I use either one of them right now? Well, let's see. Like the first one, do I know the first term? Yes. Do I know the last term? Yes. Do I know the number of terms? Do I know the number of rows? I don't know that. So without n, I can't even use the other one. So that's why there's a little bit of space there. We're going to have to do a little bit of algebra to figure out what it is. Now this one is small enough, you could probably just count evens to 24 and see how many rows there are. I mean, we'll do that in just a second. But a lot of times these problems won't be that nice to you. They'll probably ask you to add maybe 100 or 200 terms, and you don't want to sit there and just create the sequence and then go back and add every one of those. It can be done, but it's just going to take a lot of time. So let's use that formula that I just wrote a moment ago. The first term plus n minus 1 times d. Okay? So we're trying to figure out n. We have everything else. So we know the first term was 8 plus n minus 1. What was the common difference? 2. What do you think I should set this equal to? What is that? 24. The last term that I want to add in this series. That's exactly right. By setting it equal to the last term, that should give me the total number of rows that I'm looking at. Okay, well, let's do a little bit of algebra here. So 24 is equal to 8 plus, if I were to distribute, looks like 2n minus 2. So 8 minus 2? 6. And now let's subtract the 6 over. 24 minus 6. 18 is equal to 2n, so n equals 9. So there should be 9 terms that I'm adding in the series, 9 rows. Okay. And also just one note here, when you're working these kinds of problems, make sure that your answers make sense, that they're reasonable. Like, what are some values that would not make sense for this? I'm sorry? Well, could you have 100 rows? Possible, but there's got to be a limit at some point, right? I was thinking more along the line, could there be a negative? Could you have decimal or fractions? No, because you have a row or not. You're not going to have a portion of a row. Does that make sense? Okay, so just think about that. Also, you could, like I said a moment ago, if I just continued it, 12, 14, 16, 18, 20, 22, 24, 1, 2, 3, 4, 5, 6, 7, 8, 9. So see, we are correct. Okay. So now that we know n equals 9, I'm just going to go ahead and put this right here. We can go ahead and use, actually, which formula? Actually, either one. We actually have the information to use either. Plugging into either one of these should give me the exact same answer. So I would probably go with the one that's easier. Just go with the first one. S sub n is equal to n divided by 2 times the sum of the first and the last. Okay, so n is 9, so S sub 9, we're adding 9 terms, is equal to 9 halves, n divided by 2, times the first term was 8, and the last term was 24. And see, these are just formulas. You simply plug in and you simplify. A lot of algebra. Okay. So what's 8 plus 24? Okay, so S sub 9 equals 9 halves times 32. And you could multiply 32 times 9 and then take half of that, but it might be easier to simplify. What divides both 2 and 32? It will become 16 because the common factor is 2. And what's 16 times 9? 144. So there should be 144 seats in that section. It's like there's a dead spot over here on the right side of my TV. I don't know why. Or, like I said, if the sequence is small enough, see here, you're just going by 2's, 8 to 24. If I were to take 8 plus 10 plus 12 plus 14 plus all the way through to 24, it should still give me 144. In fact, that's what you had to do on a homework problem last night or this weekend, whenever you did it. How we doing? Anybody have a question? Not sure where something came from. Okay. Now, we're probably not going to spend a whole lot of time on arithmetic because you got 2 formulas. You just substitute in. Sometimes they are going to have you maybe work backwards. Sometimes they might actually give you a sum and then ask you, well, how many terms were you adding to get that? They might just give you different elements of it. Okay. But we're going to spend more time talking about geometric series because there's a little more going on there. So here are the 2 main formulas. If it's a finite geometric sequence where the common ratio is not equal to 1. Okay. Right, Xavier? Right. Okay. So I'm going to take the first term times 1 minus the common ratio r to the number of terms I'm adding divided by 1 minus the common ratio. Okay. Now this second formula here, the first term divided by 1 minus the common ratio, I am only going to use him if it's what? If it's infinite. Basically 2 conditions. It has to be an infinite geometric sequence. That means it has to go forever. And the absolute value of the common ratio has to be less than 1. Remember, I said it at the very beginning of the lesson, the only way you can get the sum of an infinite geometric sequence is it has to, starts with a C. It has to converge. If the sequence does not converge, there's no way you're going to get a sum out of that. Okay. All right. Well, let's take a look at one more problem. And this is actually as far as the other classes got today. All right. So let's see here. It says find the sum of the geometric sequence. So we have 4, negative 4/3, 4 9ths, negative 4 27ths, dot, dot, dot. Okay. Now, let's go ahead and fill in all this information here. What's the first term? That's easy. Starts with 4. No problem there. What's the common ratio? That. Okay. Well, there's a lot of that up there. So which of that are you referring to? Now you'll notice the very last term, did they actually give that to you? They didn't simplify it, right? So whatever that last term is, they put it in the form that we were looking at on the homework in the last section. The first term times r to the n minus 1. So looking at this, we know that the common ratio has to be a negative 1/3. But if I take consecutive terms, like if I were to take 4/9 and divide it by negative 4/3, should it give me negative 1/3? Yes. Does anybody want to see that just to make sure? Any takers? No. Now here's the tricky one. How many terms am I adding? I am not adding 10. I'm adding 11. Remember, the formula is based on the power of n minus 1. Whatever they plugged in for n simplified to give me a 10 for that last term. Okay, so that means n would have to be 11. Another way of doing it, do you guys remember an exponent rule? Like if I had x to the a equals x to the b? Okay. If an exponential equals a second one and the bases are identical, well then I know that a equals b, right? Well, go ahead and apply the formula, set it equal to the very last term. So this would be 4 times negative 1/3 to the n minus 1 equals the value of the last term. So we don't actually know what the last term is. 4 times negative 1/3 to the 10. These bases are identical, so I know that power should equal that power. So what minus 1 is 10? It's got to be 11. So there are actually 11 terms that we're adding here. Is everybody okay with that? And see, that's something that could throw off your entire answer, and it's something so simple. Okay, you just have to be careful with these, make sure you have the right values. Okay, well, it says write the series in summation notation. What does that mean? Is there something we looked at the beginning, like a symbol or something? What was it? Sigma, okay. So let's go ahead and write this in sigma notation. That's where we'll stop. So here's my Greek letter sigma. So we can use whatever letter you want, N, K, what do you like? W, L, okay. Let's go with W. All right, so what term number am I wanting to start with? Now, 4 is the value of what term? The first one. There we go. So I want to start with the first term, and remember, how many terms am I wanting to add up? 11. So the upper value should be 11. I want to add the first all the way to the 11th. And now what follows is the formula I would use to generate those terms based on this guy right here. So 4 times negative 1/3 to the n minus 1. Okay. And see, that formula will generate the sequence. Like, for example, let's say n equals 1. So this would be 4 times negative 1/3 to the 0, because 1 minus 1. But what's anything to the 0 power? 1, so that's just 4. See, there's my first term. Now let's say n equals 2. So that would be 4 times negative 1/3 to the first, because 2 minus 1 would give me 1. So 4 times negative 1/3, there's negative 4/3. And then you could go all the way through the 11. So there is a way to do this by hand. If you're not a big fan of the formulas, you could get every one of these 11 terms and then just add them up. I wouldn't recommend it, because what do you notice about all these fractions? They all have different what? Denominators. So you'd have to find a common denominator for all of them. That would just take time. Again, the formula is going to simplify that whole process. Okay. Questions? Anybody having trouble? Yes, ma'am. Oh, yeah, the variable itself doesn't matter. I mean, it can be whatever you want it to be. Typically, we use N, K, or I. But some people, I think, Rhett, did you say W? Or was that Skylar? I heard it come from over here. Okay. And then someone over here said L. Okay, yes, ma'am. Could you start with 0? You can, but remember, while it is possible to deal with the 0th term, we won't be. we're just going to go ahead and start with the first. All right. So good. Good. Okay, we will continue this tomorrow after a focus activity. If you turned in your homework today, I'll be passing that back to you tomorrow so that you can have that to help you study for the exam. All right. Onward and upward.